So my name is Dhaval Nagar. I am a serverless hero, and I also run a consulting and software development company based in India. For today's session, we are going to start with the current state of generative AI model. There's too much advancements and new things happening around that. Recent advancements in the model technologies, multi-model LLM models, which are becoming very common nowadays. Our customer use case, what was the problem, what we implemented, the entire solution in the serverless, and our learning and the summary. I want to start this session with a very profound quote from a popular author from last century. In his own words, he rightfully said that now the profession that we are in, we feel more joy when we discover new things instead of just knowing it right hand. I like to make coffee. This is morning coffee, one of the photos of my morning coffee. On the right-hand side is the analysis done by an AI model of my coffee cup. It's well structured. It is to the point. This was not the only image I uploaded. There were like set of images I was uploading left and right, and every single time I feel that it is actually giving very accurate output. In the last 2 years, 23 to 24, we have seen tremendous advancement in terms of models. Companies like Meta, OpenAI, Anthropic, Cohere, Mistral, Amazon's own models, they keep on releasing new models with advanced capabilities. The 2023, we saw new generation, new family of models, and in 2024, we saw the extension of those models. These models are having better advanced capabilities, higher quality, better performance, and at the same time, they are getting cost effective. In the last couple of years, we have seen tremendous technological advancements as well. So we'll look at a couple of those. The first one is very obvious, the GPUs. GPUs are like the gold nowadays, or a rare earth material. Everyone wants them. So in this week also, we saw a lot of news and advancement, a lot of news and announcements around the GPUs and how Amazon and other companies are using that. So computational demand for newer large language models are insane. They require thousands of GPUs working together. With powerful GPUs, companies can scale these models to billions of parameters. As we are seeing that every model has more billions, where it's just from the single digit to double digit to triple digit. They are just scaling it like anything. So bigger models tend to capture more complex data patterns across the data set they are trained on. Powerful GPUs, at the same time, accelerate the training process. So that is one of the reasons why we are seeing more models in a shorter duration. The next one is significant improvement in the data set and the training techniques. The data set, the quality of a model is heavily dependent on the data it is trained on. Now, compared to a few years back, where the data was very difficult to get, the data collecting and accumulating and processing on the data set has become much simplified. There are models that train on the real data, and there are models that are now getting trained on the synthetic data as well. Most models are now targeting global use cases, so it's multilingual model. So having a diversified data set across different languages allow them to generate content in different languages, ultimately making it more suitable for global audiences. Training techniques like reinforcement learning with human feedback aligns the model output with human preferences, making it more safer and quality, improving the quality of the generated content. Along with the technological advancements, there are few advancements in the model as well. These are the features, these are the improvements that we have seen in last one and a half year. The first one is The very noticeable one, context window. The context window has improved like anything, from 3,000, 4,000 tokens to 100,000, 200,000 tokens, 300,000 tokens. Yesterday's announcement on Amazon Noah is basically having 100,000 to 300,000 tokens as a default token limit. Token context window basically refers to the amount of information the model can process in a single at once. So, for example, a context window of 200,000 token can process almost 500 pages of a book with 150,000 words. That's like too much information. As a human, that's like too much of an information to read, process, analyze, and give any kind of output in a short duration. The next one is, that's also getting very common, multimodality. Compared to the earlier models, the newer models are now multimodal from the day one itself. Multimodal refers to the model's ability to process and generate content not just in the text, but in the other formats like audio, image, and video as well. Models like Amazon's Noah, Anthropic Haiku, Sonnet, OpenAI's GPT-4 are capable of accepting image, and then they can answer the questions related to the image itself. That also improves the cross-model interaction between the different modalities. So we can enter the text as a prompt, and we have the other type like image, and then it can answer the task or answer the question accordingly. The models are also getting better at reasoning and inference. Beyond the simple, straightforward question answering, they are now getting very advanced at complex analytical discussions. They also assist users by providing well-reasoned answers, explanations, and recommendations. From the earlier examples of just answering straightforward questions, now there are use cases like project planning, training schedules, travel itineraries. They are doing much more use cases immediately. The last one is agentic workflow. This is also a very popular capability. Agentic workflow transforms the model from passive information provider to active assistant capable of taking actions. With agentic workflow, model becomes intelligent agents capable of interacting with external systems, APIs, databases, and perform actions autonomously. Let's look at the two types of models that we are used to nowadays. The first one is the text models. They are primarily designed to ingest and generate the text information. They understand and generate human language based on the patterns learned from the large textual data set. They accept text and produce text as an output. And most common applications for text models are answering questions, summarizing, language translation, and identifying the tone of the text. The next one is a multimodal model. They are designed to process information from different modalities like text, image, audio, and video. They are more complex in internal design because they need to be trained on diversified data set across different modalities and not just text. This gives them the additional advantage. For example, integrating visual and auditory context along with the text improves the overall user experience. So this session is primarily focused around the multimodal model. So let's look at some of the key features of a multimodal model. The first one, again, related, larger context window. Larger context window allows to have more data in a single, as a single input and output. So this actually enhances the overall comprehension to process the text along with an image or any other type of data. This helps in complex analysis, especially with intricate images, as this use case is more around the image analysis, without losing track of the content inside the image. Improved image understanding helps interpret images with a higher precision, not just extracting the objects or identifying objects in the image, but also understand the relationship and the content or context of the image. Extracting information from visual content help interpreting and transforming the data from different data types. Like we saw in the coffee cup analysis, the input image was of coffee cup. It has to reason first what exactly is the image, how it looks like, and the output was generated in a JSON format. So it is transforming from one data type to another data type after the reasoning part. All of multi-model models are best suitable for business use cases because we don't need to transform and extract and pre-process the information from the different data formats and then make it suitable for the model processing. The model can ingest the data from different formats and then can start processing immediately. Zero-shot prompting is one of the key features of newer LLMs. It allows the model to perform the task immediately without supplying the examples or doing the task-specific training. For our use case, the zero-shot prompting was really important because most of our data were private. It was part of a business, so most of our data were private, and we really wanted to avoid the data training and fine-tuning exercise. So why zero-shot prompting is really important for business use case? The first one is it actually extracts the information without previous examples. Many of this data is available at different point in time. So having the data very recently available and then getting the required output, that is a very short time duration. So in that duration, instead of training the model with a newer data which is not fully available, zero-shot prompting allows to actually experiment faster. Newer applications or features can be implemented faster because we can immediately send data to model and expect reasonable output. Overall, it helps saving the time, data preparation, model training, and the training-related cost. So let's look at a couple of examples of zero-shot prompting. This is the image taken from a popular website. It's an image of a hummingbird sitting on a tree. So the question is, can you identify the bird in this picture? And this one was tested on Anthropic Haiku V1 using the Bedrock. And it actually gives a very reasonable descriptive answer that yes, it is a hummingbird based on the several properties and descriptions of the bird itself. For the same, as Anthropic Haiku is multilingual as well, the same question is asked in Spanish, and it actually answers correctly in the Spanish as well. So this is the immediate and a faster way to validate and get the response without actually supplying any additional information. These are all zero-shot. There is no prior information. There is no detailing added into the prompt itself. Now as this entire session is around the vision or the image processing, let's look at some of the visual examples that we tried before we reached to our use case. The first one is a visual question answering. On the left-hand side, you see a prompt which actually asked for which is the common property between these two images. So it looks very simple, but from the model standpoint, it's slightly complicated. This is multi-model chain of thought processing. The model has to first understand the image and extract the information out of that. The model has to also extract the reasoning out of the text and then compare the properties. In this case, we are asking for what is the most common property between two images. So outside, it is very simple, but from the model's point of view, it is slightly complicated. And it actually perfectly identifies that the most common property between a cracker and a fries is the saltiness. This one is a visual interpretation. This is, again, a zero-shot importing a diagram of a AWS solution. It is able to understand what is happening. It is able to understand the flow, the structure of the solution. It is able to understand the flow of the data and what the context of the entire solution. So from the left-hand side, it is an image. It's a bucket in which the files will be uploaded, which triggers the Lambda function. Lambda then calls the SageMaker, and then the final output is stored in another S3 bucket. So it actually identifies all of these things step by step. Captioning is one of the most common use case of VLM or the multi-model models which are capable of image understanding and processing. So this is another image uploaded, and the question is to describe the image in one sentence, and it perfectly understands and identifies the context of the entire image, that it looks like a working desk with a few objects around that. And grounding is also becoming a very common use case nowadays, as there are many use cases in which LLM models are now being part of the robotics and other systems. So this is a very simplified grounding. It doesn't give much detail, but actually it gives the directional detail that which object is where in the image. The much detailed grounding is identifying the object along with the precise X, Y, and height width. So this was tested on the Florence 2, which was recently launched by Microsoft. Now let's look at the use case, the customer use case that we had. So the customer, our customer was like a regular garment or a digital printing company. Their business is creating the designs, printing those designs into fabric, and then once the fabrics are printed and quality tested, delivering those fabric to their end customers, which could be brands, other organizations, and like that. So they create the raw designs. They have in-house designers. Designers use specialized tools like Adobe Photoshop, CorelDRAW, Illustrator, and then create these very detailed designs. These designs, the raw files are created in TIFF format. TIFF format has a special property, color precision. And color precision is required for very precision output on the fabric. The customer, our business has this large digital printing machines which take raw TIFF file as an input, and then they actually print the pattern onto the fabric. Once the print is done and quality tested, then it is given back to their end customers, and then they produce the garments out of those materials. So this is their business. Now, as part of the business flow, the typical business flow is to first identify for every project or every season. Let's say they have some new project for the summer, new project for the fall, new project for the winter, or some specialized project for upcoming holidays or something like that. Their first part is to create and identify a design theme. So design theme includes the design patterns they want to include and print, color palette they want to utilize for those prints, and the current trends, what is currently trending in the market, and that is something they want to include that. The next is, once the theme is identified, they will look for the example images. These example images are just for the inspiration. They can actually collect set of images from different sources, either their local database or either through the online resources. And then create a mood board. So mood board is collection of several images put together for the next project, next season, and based on that, they decide which one to work for and how they want to proceed next. The infrastructure-wise, they are into business for several years, more than 10 years now. So regularly creating the design, printing those design, and delivering the raw material, they have a decent set of image and the design library in-house. Designs are mostly stored in two different formats. The raw files are stored in the TIFF format, and there is a preview file for easy sharing across the different email or other software. All of these files are not stored in cloud. While they are using the digital infrastructure, they are not much into the cloud. The IT and software, they use the limited capacity, whatever they need for their existing business. But none of these images are yet into the cloud, and the images are in the tune of few terabytes at this point. They use private cloud storage with RAID configuration and network accessibility, just so that all of their workstations, the designer stations are directly connected and accessible for these design files. The raw files are stored. The raw files are big. They usually stored in a different format for easy accessibility. This entire process has some inefficiencies. Every time they need to get into the new project, they need to immediately go into finding the images for mood board creations. And this exercise may require time. So sometimes they are in rush of a time, and sometimes they want to quickly deliver something for their end customer. NAS works like a regular file storage, similar to Amazon EFS. It's just a network attached storage. Everything is stored as files and folders. So searching through NAS is a manual and human-driven process. So for mood board creation, depending on what they need and how fast they need, they go inside, they start manually open different files, try to understand the content of that, and then see whether that is suitable for the mood board or not. It's a time-consuming and error-prone. Because it is human-dependent, in a short duration, it's very likely that a person or a team of people may not be able to go through a vast majority of images, and they look for the images as fast as possible, and then prepare something easily. If they have shorter time and they need to deliver something fast, they use online commercial resources. It's a legitimate business, so they have subscription for many online resources where they can go search for the images, download it, and then use it for commercial printing purpose. These online resources charge them based on the images they have downloaded. They know that these images are downloaded for fabric printing and something like that, so they are charged accordingly. It's very likely that they are downloading some of the images, which not the exact one, but the similar one are already available as part of their local storage infrastructure. Cost is an added part here. Yes, they are saving on the time, but they are paying more on the cost part because of the time storage and the requirement. What we wanted is something similar to how they are using the online infrastructure, where you can go to a website or a web link, type what kind of images you are looking for. Are you looking for a floral image? Are you looking for an image with animals? Are you looking for an image with stripes, some specific geometrical patterns? You're looking for an image with specific background colors. So those are the different attributes, and this is what we wanted to build. That based on the existing infrastructure, based on the existing image data set they have, can we convert that to a searchable attribute data set or not? The attributes has to be user-friendly, because the people who are going to use this system, they will use it similar to how they are using the online resources. At the same time, the business wanted to make sure that this entire process is cost-efficient from the day one itself and in the longer run. It's not a one-time exercise. They will keep on generating new designs. They want to include those new designs as part of the overall system. So the solution, month on month, has to be cost-efficient. Low maintenance, because they do not have a full-time IT or a software team in place. So they want to make sure that they utilize the resources in a cost-efficient and low-maintenance manner. And pay-as-you-use model. This one was very important to them because they are already familiar with the model. The way they are using external resources to download specific images and pay for just that image, even though the serverless is a new term and unrelated term for them, but they are very well aware about the term that there is something like pay-as-you-go model, where you are paying for what you are basically consuming. So as we started, we immediately hit with our first challenge, that the raw files and the design files are just too many and scattered all over the RAID system. So the data set is pretty large, and we don't want to upload the entire data set into the cloud first and then start processing. Some of the design files, the TIFF files, the resolution of the TIFF file depends on the overall design they want to print. So some of the design files are smaller, like 1024 by 1024 in the resolution, and some are pretty large, 25,000 by 25,000, 25,000 by 40,000 in resolutions or dimensions. So these are very large, very diverse set of images across the data set. Again, not all design files are required for the attribution, because sometimes they create a lot of copies with a variation, so they don't want to process every single variation. They need a way to selectively identify and process those images for attributions. And the entire data set is just unstructured, so there is no metadata stored along with the files. It's just files and folders, and with a very limited information around those. So based on our early experiments, not just with the coffee cup, we were processing many other documents, receipts, and few other things. We knew that the generative AI technology can be very effective in converting unstructured data to structured data. We just needed to find a way to bridge the gap. So we'll start looking at how we build the solution step by step. So before we started, we put some guardrails that will work in this framework. Instead of just going with a random selection with different things, we'll keep this in mind whenever we are evaluating something. Either it is different services that we are evaluating, or how we are going to process it, where we are going to process it, and what the end result will look like. So we put a small framework in place that will experiment with the budget. It has direct process impact. That means at the end of the process, we should have the searchable attribute database. Privacy and security is going to be maintained because the customer don't want to upload these images or make these images public. They want to keep it private and secure. And as we saw in the earlier slide, the entire solution from the early development to continuous maintenance, it has to be a low-cost solution. So we put an example that if this is my input image, this is a very, very simple image. It's an animal print, leopard print. It has a very specific pattern, a background color, foreground colors. It's a multicolor print. So if we give this as an input, it should generate this as an output. Okay. I don't know whether they are readable or not. So this on the right-hand side is a set of attributes. The attributes are patterns. So pattern is a name. It's an animal print. It's a leopard print. The colors are orange, black, brown. Background color is prominent orange. Animals, there are few Boolean attributes as well. Like it is an animal print. Yes. It's a multicolor. Yes. It's an adult print. So it is meant for the adult specific garments. And it's a kids print, false. So in this case, it is not suitable for kids, but this is something that is still subjective. So once we had this, we actually divided the whole solution into 3 parts. The first is identifying which images to process, processing the images and generating the attributes, as we saw, and then making those attributes searchable. So before we started processing, and based on some of the trials, we made 2 important decisions. The first one is to pre-process these images on local infrastructure, not in the cloud. The reason is local infrastructure had everything that we wanted. So we'll do some basic processing there, and then upload the image to the cloud and do the further processing. And the next one is using the generative AI model instead of a machine learning model. So in the further slide, we'll see that we used a machine learning model as well for the analysis. Now, processing the images on-prem infrastructure had multiple advantages. First of all, it was immediately a low-cost solution. Everything is already there and paid up for. Due to the large data set, varying file sizes, multiple copies of the same file, it is very difficult to identify which images needs to be processed and how it needs to be processed. So we thought that local infrastructure will be the best place to start. The customer already had a stable private storage cloud. So RAID configuration with network accessibility. So it is very stable and it is decent enough connected from the entire premise. So the overall volume was in multiple terabytes. So instead of uploading into the cloud first, the local cloud is sufficient to do the identification and processing. And most of the workstations are equipped with GPUs because they use softwares like Photoshop, Illustrator. So their designers use the workstation which has GPUs. That makes the job much easier if we need to run anything additional on top of that, especially for the image processing part. So this is an example image. It has a lot of detailing. It has a lot of objects. So this image is very large in terms of a size. And if we process the entire image, yes, it will give a very good, optimal, precise output. But if we use the entire image, it will be too costly because the image is too large. And it's not just one image, there are thousands of images. So first we decided that we'll actually bring some consistency in this all images before we start processing. So we started with a segmentation or an image sampling. So instead of resizing or processing the entire image, we thought that we'll extract a part of the image and that we will use for processing. So the part will look like this. This small part also has decent amount of information. It captures the background information. It captures the objects, some of the objects which are very repetitive if you see the entire image. And the segments are variable. So we are not extracting one segment per image. We are extracting the number of segments depending on the size and the resolution of the image. So if the image is less than certain resolution, like less than 5,000 by 5,000, then we extract one segment. If it is beyond that, then we divide the image into multiple parts, and from each part we take a segment. So that way we can cover the larger portion, but we are still very uniform across all these partitions. Segment has unique properties. The first is now all of these segments are very uniform in size. They are 1024 by 1024, which gives them a consistent resolution, and we also reduce the size. Sufficient detail is covered. It has prominent background color. It has objects also covered. It is optimized in terms of a storage. So now if you are uploading thousands of images back to the cloud, we know that we'll not be spending a lot on the storage as well. And this entire process is repeatable. Why? Because we are doing all of these things in the local infrastructure. So until these images are validated and we think that it is right, we are not uploading it to the cloud, not spending any more on the cloud cost. So these are some of the segments. If you look at the images, every image is very unique. Every image has unique pattern, unique background, and different contextual properties. As a human, looking at these images, it becomes very simple and evident for us that what exactly the image is trying to convey. But for a system, it is much more challenging and complex. So like this, we started with a few hundred segments first, and then we eventually moved to thousands of segments per image. As I mentioned, that we had to take two critical decisions. One is to process the images on the local infrastructure and extract the segments. The second one was, instead of using the machine learning model, we'll use the generative AI model. So the first model, the first service that we tried was Amazon Recognition. So Amazon Recognition is a fully managed service which actually is capable of image recognition, audio analysis, and image analysis. It has a variety of use cases. It can detect object, scene, faces. It can actually detect celebrities as well. It can extract text as part of their OCR capability, and it has an ability to extract certain image properties. So we thought that this is a good place to start and see that what kind of image properties it can generate from this variable or different types of images that we have. It's a fully managed service, and we pay for the per image analysis cost. So it was fitting into our basic framework. We are more interested into image properties. So when we started processing image like this, we received the properties like this. Now, one basic property that was useful for our use case were dominant colors. It returns the color in a hex format, which is easy to convert into human-readable colors as well. But that was the only property that was most suitable for our use case. Everything else was not directly relevant or not required, like brightness, sharpness, or the contrast of the image. And Amazon Recognition can do more than this. But for that, we need to train it with our custom data set. And that is something we wanted to avoid. That means we have to first prepare the entire data set, train with a recognition, and then labeling this hundreds and thousands of images having unique properties is a challenging task itself as well, a time-consuming and cost-sensitive exercise. And we wanted something like this. So we thought that the recognition is not the right service, and we have to look for another option. So Andrew Ng gave a very popular session late last year at Stanford, and he mentioned one part very clearly, that there are hundreds of use cases which used to take months to build, including the human skill set, resources, and the higher cost, can now be implemented in a very short duration of time using the generative AI model. So we started experimenting, we started feeding all of this to the generative AI model, and Cloud 3 launched Anthropic launched the Cloud 3 generation of family in the March this year, and they were immediately available on Bedrock. One of the things they had mentioned in their early release was this generation of the models are very good at visual understanding and processing. So that means by providing certain image with a very intricate detail and everything, it will be able to process and return the expected output. And we saw that in the, not just in the coffee cup analysis, we fed different diversified set of images before this use case as well. So by giving cloud, we started with Haiku because Haiku was very cost efficient and performant compared to the other two models, Sonnet and Opus. They are slightly more advanced and more costly. So given this as an input image, it generates this as an output. This is something we wanted from the day one itself. It has all the matching properties that we wanted in our overall solution. If you look at the right side output closely, it is a structured JSON format. It has the pattern with a correct name, animal and leopard. It has all the colors properly identified, orange, black, and brown, and the background color is also identified, orange. These are human-readable color format because we want it in regular text keywords. These keywords will become our attribute database. So that's why we wanted everything as a text keywords. After the initial analysis, we started feeding more. We refined our prompt and started adding more attributes. Can we extract more information? If we have extracted this much, can we have more or not? And it was actually based on a few dozen different, very unique images. It was actually able to identify a lot of properties. So at the bottom, there are many other properties added, like does it have a shape? Does it include people, like faces and full people? Does it include animals? Does it have flowers? Does it have fruits? Does it include stripes or not? So these are some of the properties that we added, and it was able to very accurately identify those properties as well. Now at this point, and before we go into the solution, let's look at the processing cost. So Haiku was priced at 25 cents per million input tokens. It is still priced at 25 cents per million, but there is a version 2 of Haiku now available, very recently available. Anthropic does the calculation based on the number of tokens we consume. So there are certain models that actually charge if you have text and image, so they charge separately for the image addition, but Anthropic actually combine everything together, and then they give you a consolidated cost that this much token you have consumed. So based on the token consumed, this is the cost of your input and output. So the simple calculation is the image resolution divided by 750. So width into height divided by 750. And in our case, we had an advantage because every segment was 1024 by 1024. So that actually brought down the per image tokens to roughly 1400. We had our prompt, full prompt. The prompt was taking 200 tokens. So overall, it was 1600 tokens for a single image analysis. We were not using the batch. We were using the single image for each transaction. For every single image, including the text, we were consuming 1600 tokens. The cost of per image analysis was 0.0004. That's a very high, that's a very low number. So just as a second example, the cost of processing 1,000 image was coming down to 40 cents. And this was immediately we thought that this is the best thing that we can do. This is what we wanted because it reduces the overall cost drastically to well within our budget, well below our budget. Perfect combination of cost versus the performance because we were able to extract all the required attributes and at the same time, it was very cost effective. So at this point, we had everything in place. We had the segments in 1024 by 1024. We know that this is the model we'll be using. We know what the model is going to return as an output, and we need to just put everything together and build our solution. So we started the high-level process flow is uploading the image to AWS cloud, processing the image and saving all of these attributes into SQL database, and then building the APIs and make these attributes searchable. That is the very simplified workflow at this point. So for image processing on AWS, we again kept it very simple. We used all the managed and serverless services. We upload these segments into an S3 bucket. We have a cron job in an event bridge, which actually starts at a fixed schedule. Instead of doing everything in real time, we start it like once a day. It starts a step function. And step function does rest of the job of integrating with different services and saving the attributes into the file, into the database, sorry. For Haiku interaction, we use Bedrock because instead of using the direct Anthropic API, we thought that we'll keep everything within the scope of AWS. Bedrock is a fully managed service. It has number of models across different companies like Amazon's own model, Titan models, Cohere, Meta, Anthropic, Mistral, and Stability AI. Just today, they launched that now they are allowing 100 plus new models as part of extension, which is a very good because Bedrock has a single API. If any of you have interacted with a Bedrock, invoke model is the uniform single API. You can actually use one API and you can switch between the models. So we wanted to switch between the models throughout our experimentation. So we decided to go with Bedrock. The added capabilities are, for our use case, the private accessibility. So we can actually use the Bedrock over the VPC using the VPC endpoint. Flexible, very flexible pricing. In this use case, we only pay for what we are consuming for each image analysis, and we are using on-demand. It has provision throughput for the lower cost, and it has a batch mode available as well. So Bedrock has evolved into much complicated. If you have seen the recent announcements, from the beginning, a very simplified, a unified service. Now it has evolved into much complicated with a lot of features like guardrails, agentic workflow, knowledge base, and many other things. So this is a very simplified API interaction to Bedrock. It's a simplified version because we are not changing some of the other parameters like randomness, the top K, top P, or we are not changing anything. We are just using the default values, and the only thing we are focusing is the image that we add into the prompt, which is a base 64, the rtext prompt, which is a fine-tuned prompt to extract the attributes, and the model ID. So the model ID in this case, as you see, it is a model released on March 2024. We are still using the same model. We are continuing with that because it still gives the optimal output. For the database, we used Aurora Serverless V1. It actually fit into our framework. It's a fully serverless. It's a SQL, so we use MySQL. It has the data API support. So because our use case was very simple, we wanted to use over the HTTPS instead of using via the ORM models. It has unique feature of auto pause and resume. This is something we wanted because our business is they run in a fixed hours. And for image searching is a random activity. It's not something that people will use throughout the day. It is something they'll use as and when they required. So we wanted something where the infrastructure is available when needed. And database, in any solution, database is only part which will be more costly compared to other services. So this has the ability to auto pause and resume based on the demand. And it has a very faster sufficient startup time. So we validated that, and we realized that this is a perfect fit for our solution. It's very cost effective because we do not run it 24/7. It starts up when needed. It automatically goes down if it is not in use. So these are the three properties we wanted, and then it was fitting into that. So we continued with that. Although V1 is now deprecated, so October 31st was the deadline, and our solution still runs on V1 because the migration deadline is 31st December. So we still have sufficient time to migrate to. And we have decided to migrate to V2. Now V2 is expensive. V2 has similar properties, but V2 is expensive, and there was no scale to 0. So the baseline capacity, baseline ACU was 0.5, which still makes it very expensive compared to V1. Good thing for us, Amazon just announced, now it can scale down to 0. We tested it, we already tested it in the different environment, and we are migrating, in this month we are migrating it to V2. So now let's look at the overall diagram. So we upload the images to S3 bucket. Event bridge, cron schedule starts the step function. The step function first, the Lambda functions within the step function first checks whether the database is ongoing, running or not. Because we are using V1, chances are that whenever we are doing something, the database might not be up and running. So that's the first thing we do. We ping the database and ensure that the database is up and running. Then we start pulling the images that are ready for processing. We process all the images through Bedrock and Anthropic Claude 3 Haiku model. We save the attributes into the database, and we save the consolidated attributes which we are using as filters into DynamoDB. And I'll showcase why we are actually saving the high-level filters into DynamoDB. So this was our backend flow. Our front-end flow was very simple. The user, because this is a business use case, we are using the Cognito. The website is hosted on S3 CloudFront. The user logs in through Cognito. That calls the API gateway. API gateway calls the Lambda function and retrieves all the filters required for that landing page. The name of all the patterns, the colors available, the background color, foreground colors, and all those properties that we want the user to basically apply. Those are available from the DynamoDB, and we can immediately send it to the UI. And then actual search happens against the Aurora serverless V1 database. And the images, we show the images. Those are these exact images that we actually preview into the UI as well. Those are also those are coming from the S3 process bucket. So we have a demo, a short, very quick demo. So before I go into that, I just want to highlight a few things. So we processed close to 6,000 images. We identified 300 plus unique patterns. These are very diversified set of patterns. It was very quick to put all of this together, even though it looks like we have done so many things, but overall solution took less than few weeks to implement and make it ready for the business. And it was cost effective because we managed, as you saw the diagram, every service was fully serverless, pay-as-you-go managed services. So we pay based on the consumption. The unique thing about the serverless services is all of these services have very generous free tier. So if your use case is very stable, very predictable, and if you are below that, the chances of you running out of and having additional cost with time are very minimal, because we know that it will grow as the business will grow and as the users will grow. So we are well within the free tier across all of the services. From the beginning, we kept the entire process flow very simple. We had a constant feedback loop with the customer and internal team. We used the low maintenance, low cost infrastructure for the entire solution. So now I have a quick demo. So this is how it starts. The user logs in. On the top, you will see the different attributes. So these attributes are stored in DynamoDB, and we retrieve from there, because at this point, we are still not checking whether the database is up and running or not. And here, the user is selecting various attributes and trying to search the images based on those attributes. Now, this is a key decision that we took. We told our customer that when you try to search it, it is very likely that first time you will hit with an error, that the database is not running. And they were very curious that why you are doing something like that. And we explained in a very simple way that if you do this, it will be very cheap. You have to wait for a few seconds, but it will be very cheap overall. And they agreed. They said it's fine. Waiting for a few seconds is just fine. Version 2. So once, after a few seconds, if you hit again, it actually, based on the selection, it retrieves all the suitable images with the preview images as well. It has the right naming format, because these are the images in the cloud. For the original file, which are still stored in your local RAID system, you need to go back and then retrieve those files. So we maintain the structure, the naming, and all other things intact, just so that people can go back to their RAID and then search the file using the local file system browser. So these are the different attributes, different images that they have. These are still a very small database in the demo. We have a very large set of images. So this makes it very simple or similar to how they are using the online resources like Shutterstock or something. Few key points. Serverless and managed infrastructure helps in really rapid development. We were able to put all of these things together in a very short duration of time because of the managed services. Generative AI model, yes, we had our own doubts that doing it on few images or few dozens of images are fine, but can it scale it to hundreds and thousands of images? But yes, we still are seeing a very optimal, very accurate output across all the images. There are, yes, every now and then, like we saw, that animal print is not suitable for kids. It's a different perspective. I think it is suitable, but from the model standpoint, it is not. So there are some errors, but otherwise it is still very accurate. Becoming commodity for a service like Bedrock, which allows to switch between the model, it makes it very easy to try with a different model. So with a very simple configuration, we tested with Sonnet as well and check the output. And if it is almost similar, we can switch back to the Haiku as well. Now they have, very recently, they have announced the prompt routing, which is a very unique, very powerful capability. And I think it will open up a new set of use cases in future. Pay-as-you-go model, all of these services we are paying for what we are consuming. And every use case is different, but we kept on experimenting, and after every experimentation, we learned something new that helped us in the next step. Focusing on the problem was our key part. LLMs are really, really advancing. Compared to the last year, the newer generation, the newer frontier models have much more powerful capabilities than just answering straightforward questions. And the using the cloud infrastructure intelligently, we can actually reduce the cost drastically, and at the same time, we can actually make it all private, secure, and future-proof as well. For many businesses, cost is a huge factor. Like I mentioned, with a very simple line that if you are okay with a simple error, it will reduce the cost drastically, and they were happy with that. So for a lot of use cases, cost is still a very huge factor. Thank you. Thank you for your time.